The next type of wave that we're going to talk about is light, and this is completely different from a mechanical wave because light really is independent of any, well, it doesn't need a medium. Light can go from the sun to us through the vacuum of space, whereas sound has to have something to go through, whether it's air or water or some sort of solid thing. Sound needs a medium to disturb. Light doesn't need a medium because light's tricky, light's funny, light's its own little deal. So light is an electromagnetic disturbance. It's a traveling electromagnetic disturbance. And we talk about light two ways, and this may be kind of tricky, but what we say is that it's two things. One, it's particle. And this kind of helps us deal with the, not needing a medium. And we see light as a particle in things like its interaction with electrons. That's absorption and emission spectra stuff that you guys talked about. That's absorption and emission spectrum stuff that you all talked about last year in chemistry, where a light wave comes in, hits an electron, and moves it up to a different energy level. It's easier for us to think of light as a particle that way. Another way we see light as a particle is something called the photoelectric effect. In the photoelectric effect, you have different wavelengths of light hitting a piece of metal and knocking electrons off. If you ever want to see that, put a piece of foil or a fork in a microwave. Okay, those sparks are the photoelectric effect. That's kind of how it works. The other way, and the way that we're really going to concentrate on light, is that it behaves like a wave. And this is what we're used to thinking of light as. So for a wave, we see it in diffraction. Talk about that a little bit. We'll see it in reflection, obviously. And we'll see that in refraction. All three of these things sort of give us evidence that light behaves like a wave, like everything else does. We also see light interfere. And that's really what diffraction is all about, is the interference of light. But it acts like a wave. So, for us, this is how we're looking at light. Looking at light as a wave. It's both things, two things at once. It's a weird quantum thing, and if you want to get into that, it may not be a discussion we have in class, but it's certainly one that we can have. So, the thing about this traveling electromagnetic disturbance is that it can only and always ever travel at a certain speed. 3 times 10 to the 8th meters per second. And that's in a vacuum. Nope. 3 times 10 to the 8th meters per second in a vacuum. We use a little c to denote that because it's constant and it always works this way. In fact, this is the universal constant. As we travel through air or glass or water or diamond or a salt crystal or something like that, light's going to move slower. But in a vacuum, this is as fast as it gets. In fact, this is as fast as everything gets. This is our speed limit. Nothing can move faster than light. So, that's light in a nutshell. We're going to start talking about these different things in light, and I'm going to start talking about the electromagnetic spectrum next. This is light. This is its speed. All light travels at this speed. That's how it works.